Lesson 1-2, page 18. Let's start with the key concept. To convert from the fraction form of a rational number to its decimal form, divide the numerator by the denominator. Divide the top by the bottom. The decimal form of a rational number either terminates, it ends in zeros, or eventually repeats. So let's look at one that terminates. So we've got 3/4 here. So I divide the top by the bottom, and I set it up like so for long division. And I know that 4 doesn't go into 3, but it does go into 30. 7 times 4 is 28. When I subtract, I get 2, and I bring down my 0. 4 goes into 25 times. 4 times 5 is 20, and my remainder is 0. Because my remainder is 0, I know that my decimal terminates. It does not keep going. So I know that 3/4 is equivalent to 0.75 or 75 hundredths. Okay? Now, a repeating decimal. So I divide the numerator by the denominator. 6 does not go into 1, but it does go into 10. It goes into 10 one time. So 6 times 1 is 6. I subtract that from 10. 10 minus 6 is 4, and I bring down my 0. Now, how many times does 6 go into 40? It goes in 6 times. 6 times 6 is 36, and I notice that I end up with a remainder of 4. So even if I were to add another 0 and bring it down, I'd be back at 40. How many times does 6 go into 40? Well, 6 times. So that 6 is going to keep repeating. And that's why I represent that 6 with a with a line over that 6. So 1/6 is equivalent to 0.16 repeating. Okay, now I do want to point out that we knew that this would be a repeating decimal because that denominator is a multiple of 3. And multiples of 3 will be repeating decimals. Okay, let's look at these do you understand questions. So the essential question, how are rational numbers written in decimal form? So the decimal form of a rational number must do one of two things. It must terminate, which means it must end, or it must repeat. So that's really important that you know that. It must terminate or come to an end, or it must repeat. Okay, let's look at number 2. How can you use division to find the decimal equivalent of a rational number? Well, divide the numerator which is the top, by the denominator, which is the bottom, then you'll find digits in the quotient, remember the quotient is the answer, until you get a remainder. of 0 or until the decimal numbers repeat. Okay, so divide the numerator by the denominator, find digits in the quotient until you get a remainder of 0 or until the decimal numbers repeat. Number 3, what is the difference between a terminating decimal and a repeating decimal? Okay, so let's talk about a terminating decimal first. So a terminating decimal is a decimal number that comes to an end. Okay, that's what it means to be terminating. Now let's talk about a repeating decimal. Okay, so a decimal that repeats has repeating digits. That means one or more digits keeps showing up and in the same order or in the same pattern. The digits repeat. Okay, looking at do you know how? Number 4, what is the decimal equivalent of each rational number? So let's start with A. I have 7/20. Well, I cannot reduce that, so I'm going to just start with some long division. Actually, no, I'm not. I'm going to look at my denominator here. Can I get from 20 to 100 easily? Yes, I can. I can multiply by 5 to get to 100. So I'm going to do that on the top and bottom. 7 times 5 is 35. And 20 times 5 is 100. So now that I have it like this, I can write that as a decimal as 35 hundredths. Okay, moving on to B. So this one, I also have 20 on the bottom, but I have a number that's bigger than 20 on the top, so I'm not going to do the same thing here. I'm actually going to go old school and use long division. Okay, so we know 20 goes on the outside, and my numerator, 23, goes on the inside. Now I do want to point out that this is negative, so I know that my quotient has to be negative. Now, how many times does 20 go into 23? It goes in one time, and I get 20. When I subtract, I get 3. And I'm going to add a decimal and a 0 to bring down. How many times does 20 go into 30? Well, it goes into 30 just still one time. 1 times 20 is 20. When I subtract, I get 10. I'm going to add another 0 and bring that down. How many times does 20 go into 100? It goes into 100 5 times. 5 times 20 is indeed 100. So my remainder is 0. And my quotient, or my answer, is negative 1.15, or negative 1 15 hundredths. Okay. C, I have 1/18. Okay, now when I look at this, I see that I've got a multiple of 3 on the bottom. Because it's a multiple of 3, I have an inkling that this is going to be a repeating decimal, but let's use long division to find out. So, remember, our bottom number goes outside, top number inside. 18, it doesn't go into 1, so I'm going to go ahead and add a decimal and a 0. Can 18 go into 10? Still no, so I'm going to place a 0 there. And I'm also going to add a 0 here. Can 18 go into 100? Yes. I'm going to start with 5 times because I know that 20 times 5 is 100. So 5 times 8 is 40. 5 times 1 is 5 plus 4 is 9. So I get 90. When I subtract, I'm going to get 10, and I'm going to add a 0 and bring that down. Okay, so I'm back in the same place. How many times does 18 go into 100? It goes in 5 times. 5 times 18 is 90. When I subtract, I get 10, and I am in the same scenario. So I know that that 5 is going to continue on. So I know that my decimal equivalent here is 0.05 repeating. 0.05 repeating. Okay. And finally, number 6. Again, I have a negative number, but I notice that I have 2 even numbers. 60 and 22 are both even, so I'm going to try to reduce this. So I'm going to divide by 2 on the top and bottom, and I end up with negative 30 over 11. Okay, so I can't keep going, but these are smaller numbers. They're easier to work with. So let's start with division. 11 goes on the outside, 30 on the inside. We know our answer is going to be negative. So how many times does 11 go into 30? Well, it goes in 2 times. 2 times 11 is 22. When I subtract, I get 8. I'm going to add a decimal and a 0 and bring down that 0. How many times does 11 go into 80? 11 goes into 80 7 times. 7 times 11 is 77. When I subtract, I get 3. I'm going to add a 0 and bring that down. How many times does 11 go into 30? It goes in 2 times. 2 times 11 is 22. When I subtract, I get 8. And are you seeing a pattern here? Even if I were to add another 0 and bring that down, I'm going to have 7 up here, and my pattern is repeating. Okay? I would have 2 next, 7 next, and so on. So the decimal equivalent for negative 60 over 22 or negative 30 over 11 is negative 2.72 repeating. 2.72 repeating. Okay, so we figured out the decimal equivalent of each of these numbers. I do want to point out that A and B were terminating decimals, while C and D right here were repeating decimals. Remember, we represented that repeating with the line over the digits that repeat. Okay, moving on, number 5. There are 5,280 feet in a mile. What part of a mile in decimal form will you drive until you reach the exit? So we see that the exit is in 1,000 feet. So we are going to drive 1,000 out of 5,280 feet. Now, because both of these numbers end in a 0, I can take those off. So I'm really already just looking at 100 over 528. So I know that I can divide 100 by 4. I'm going to see if I can do the same thing with 528. So 4 goes into 528. 4 goes into 5 one time. I get 4. 1 is my result. Bring down that 2. 4 goes into 12 3 times. I get 12 exactly. 0, bring down that 8. 4 goes into 8 2 times, which is 8 exactly. So 4 works. So I can divide by 4 on the top and bottom. Okay, so 100 divided by 4 is going to give me 25. And I know that 528 divided by 4 is 132. Okay, so I have an odd number and an even number. So let's think about my threes trick. Does my threes trick work here? Well, 2 plus 5 is 7, so no. So I think that's as simple as I can get this fraction. I've reduced it all the way down to 25 over 132. So I'm going to use those numbers to divide. So we're going to set up our division bracket here, and we're going to put our numerator inside and our denominator outside. So can 132 go into 25? Well, nope, it cannot. So I'm going to add a decimal and a 0. Okay, so now can 132 go into 250? Yes, it can. Now, here's what I know. 130 times 2 would be 260. So I don't think 2 is going to work here. So I'm going to start with 1. So 1 times 132 is 132. Now I'm going to borrow. This 5 I'm going to turn into a 4, and this is a 10. Now 10 minus 2 is 8. 4 minus 3 is 1, and 2 minus 1 is 1. So I have 118. So now I'm going to add a 0 and bring that down. And I'm going to ask, how many times will 132 go into 1,180? So I know it's going to be kind of a big number, but it's not going to be 10 or 9. Because when I think about 10, 130 times 10, that would give me 1,300. So I'm quite a ways away from that, but not too far away from that. So, you know, only 120 away. So I want to try 8 and see if 8 works. 2 times 8 is 16. 8 times 3 is 24, plus 1 is 25. 8 times 1 is 8, plus 2 is 10. So I get 1,056. Okay, so now I'm going to subtract that. Okay, so I'm going to borrow. This 8 becomes a 7. That's a 10. 10 minus 6 is 4. 7 minus 5 is 2. And 1 minus 0 is 1. So I have 124. So again, I'm going to add a 0 and bring that down. How many times will 132 go into 1,240? Well, I know that if I multiply it times 8, I get 1,056. Let's try 9 this time. 9 times 2 is 18. 9 times 3 is 27, 28. 9 times 1 is 9, 10, 11. So I get 1,188, and I'm going to subtract that. Okay, so I'm going to borrow. This becomes a 3. That's a 10. 10 minus 8 is 2. 3 minus 8 does not work. So that becomes a 1. That becomes a 13. 13 minus 8 is 5. So I get 52. So we're still working. We're going to add a 0, bring that down, 520. How many times will 132 go into 520? Well, it's not going to be too many times, because that's kind of close to 150. 150 times 3 is 300. Or sorry, 150 times 2 is 300, times 3 is 450. So let's start with 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 1 is 3, 396. I don't think I could have gone up to 4, but let's subtract. So that's going to become a 1. That's a 10. 10 minus 6 is 4. Now 1 minus 9 does not work, so that becomes a 4. That's an 11. 11 minus 9 is 2. 4 minus 3 is 1. So I have 124. And I feel like that is familiar. If you look up here, we already had 124. So even if I were to add a 0 and bring it down, I would start to repeat. And I would repeat with that 9, and then I'd have a 3 and a 9 and a 3, and it would continue. Okay, so the answer is, what part of a mile in decimal form will you drive until you reach the exit? So our answer is 0.1893, repeating. I put a line over 9 and 3 because those digits will repeat infinitely. And that's how far you're driving. For homework, I want you to do pages 19 and 20, and we will check that in class tomorrow. Y'all have a wonderful day. Bye.